Welcome, aspirants, to another rapid-fire Rungta IAS Masterclass Explainer. I'm your host, and today, along with my co-host, we are decoding a highly crucial development from the India Meteorological Department. It's a shift that directly impacts the absolute backbone of India's agrarian economy. Isn't that right?
Absolutely. Good day, students. Listen, this topic is an absolute goldmine. We are mapping this directly to your GS Paper 1 Geography and your GS Paper 3 Agriculture and Technology syllabus. Let's dive right in and understand the mechanics and the real-world impact of this new forecasting model.
Here is our quick academic roadmap for today's session. We'll be looking at 1. Syllabus context and relevance, 2. The district to block level shift, 3. The technology behind the forecast, 4. The El Niño challenge, and finally, 5. Mains and interview preparation. Notice how this flow mirrors the exact framework you should be using to structure your mains answers. Let's kick things off with Section 1, Syllabus, Context, and Relevance. Now, as you all know, Indian agriculture has a deep, fundamental socioeconomic dependence on the southwest monsoon. The accuracy of these monsoon predictions can literally make or break the sowing season for millions of our farmers.
Exactly. Historically, we track the monsoon using broad regional onset dates, like we know it arrives in Mumbai around June 10th or Delhi around June 29th. But here's the geographical reality you really must understand. The inherent variation of the monsoon is so high that even after it officially arrives in a given district, several blocks and villages within that exact same district can remain entirely, completely dry.
Which brings us to Section 2, the district to block level shift. If UPSC asks you to evaluate the progress of meteorological interventions in agriculture, this right here is your core argument. We are witnessing a massive paradigm shift from the generalized to the hyperlocal.
Let's break down this shift. The old system provided state or district-level forecasts. Helpful, sure, but totally lacking the granular accuracy a farmer actually needs on the ground. The new system, it provides hyperlocal, block-level forecasts. And this matters because it was specifically developed at the request of the Ministry of Agriculture and Farmers' Welfare. It allows them to deliver precise, weekly advisories so farmers can time their sowing perfectly, avoiding massive crop losses. And the number 3,196 brilliantly illustrates the scale of this initiative. That is the initial number of blocks covered by this new system spread across 15 states and 1 union territory. Crucially, as the IMD noted, these specific states are located right within the monsoon core zone, regions that are largely rain-fed and highly sensitive to southwest monsoon dynamics.
Moving on to Section 3, Technology behind the forecast. Let's pivot to the science and technology aspect of your GS3 syllabus. How exactly is the IMD generating this incredibly granular data? Let's look at the engine powering these predictions.
You definitely need to memorize this term for your prelims and mains, the Mithuna model. Mithuna is a high-resolution weather model operating at a 12.5-kilometer scale. What makes this so special is the blending framework developed by the Indian Institute of Tropical Meteorology, or IITM. They're blending nearly a century of meteorological data with global models using artificial intelligence to issue highly accurate, 4-week probabilistic forecasts. Let's walk through how this downscaling actually works. Step 1. The Mithuna model runs at that 12.5-kilometer resolution. Step 2, we feed it extensive, real-time observational data from automatic weather stations. Step 3, the forecast is downscaled. For example, in Uttar Pradesh, because they have very extensive coverage of weather stations, the IMD has just successfully launched a downscaled forecast at an incredible 1-kilometer resolution, valid for 10 whole days. That is a real game changer. But let's look at Section 4, the El Niño challenge. We now enter the critical analysis portion. No UPSC answer is complete without critically examining the hurdles, and this year, the system faces a massive one.
Let's analyze the sobering insight from the Secretary of the Ministry of Earth Sciences. He states the system faces a formidable test due to expected below-normal rainfall caused by a developing El Niño. Students, as you know from your climatology basics, El Niño frequently causes weak monsoon rain in India starting from July. This climatic anomaly is going to act as a massive stress test for the accuracy and reliability of this newly launched forecasting system.
Which leads us to our final stop, Section 5, Mains and Interview Preparation. It's time to crystallize this entire explainer into high-yield, reproducible bullet points that you absolutely must add to your revision notes today.
Keep these key takeaways ready, the IITM blending framework, the direct, weekly, and 4-week probabilistic forecasts, the focus on precision sowing for farmers, and the critical dependency on observational data. Remember, any future nationwide expansion of this system relies heavily on state governments stepping up and sharing their local weather data to allow for that downscaling. Be sure to integrate these exact points into your GS3 agriculture policy answers.
We'll leave you with this multi-layered mock interview question to ponder. How does the shift to block-level forecasting, utilizing downscaled models like Mithuna, mitigate agricultural risks posed by a developing El Niño? We encourage you to formulate an answer that seamlessly connects the geographical concepts of El Niño, the technological solutions like the Mithuna model, and the ultimate socioeconomic impacts on our farmers. Keep setting hard, aspirants. We'll see you in the next Masterclass Explainer.